following is a description of the components and actions inside an image intensifier tube, which forms part of the fluoroscopy system in the radiography department. The X-ray photons are emitted by the X-ray tube at a low dose rate, since it is a continuous beam of X-ray energy being generated. The purpose of the intensifier tube is to enhance the low-dose X-ray beam, so that the final image on the output monitor has optimal contrast and resolution in detail. Please note that the distance between the first two red layers are not to scale. This is a schematic impression and not the true distance of the fluoroscopy tube layers in the radiography department. To depict the process of the X-ray beam through the fluoroscopy tube, the red layers have been separated to demonstrate the purpose of each. The first red layer on the left is the input phosphor, or fluorescent screen, which converts every X-ray photon, reaching it into a stream of a couple of thousand times more light photons. The second red layer is the photocathode, which in turn converts these photons into negative charged electrons. The next important components are the focusing electrodes shown in yellow. These are actually negatively charged rings around the negative electron beam. Since both are negative, the electrodes force the electron beam into a cone, which projects a smaller size image onto the output phosphor. This larger surface of the input fluorescent screen, being reduced this way onto a smaller surface, leads to minification gain. The positively charged anode ring at the end pulls the negatively charged electron beam to it, and so accelerates the electrons. This acceleration energizes the electrons and is part of the flux gain. The output phosphor layer converts the electron beam to visible light photons. This conversion rate of X-ray photons to light photons is how the final image on the output monitor provides optimal contrast and resolution in detail during the fluoroscopy examination in real time. The last item in the image intensifier tube of importance is the Charged Coupled Device Sensor, or CCD. The CCD functions similar to a digital camera which receives the light, codes the light photons into an electronic signal which are again decoded as an image on a monitor, known as analog to digital conversion.